Hello, this is Andy Schweitzer putting the finishing touches on our gases mathematics. This is what we sometimes most scientists call PVNRT. PV equals nRT. Very often this is referred to as the ideal gas law. Now remember, an ideal gas is one that every particle acts the same. The identity of the particle is not a determining factor in its behavior. Important. So, in this equation we have pressure, we have volume, we have N is the number of moles, actual number of particles, R is a constant that is called the universal gas constant, and then we have T is temperature. Now, the ideal gas law with all these variables doesn't ever include the identity of the particle. Nothing here indicates that this is oxygen, carbon dioxide, nitrogen gas. It doesn't say, because it doesn't matter. There are no interactions between particles, so it does not matter. Now, a few things here. Universal gas law constant. This is a number that mathematically links everything else together. So if we're using, let's say, pressure in atmospheres, volume in liters, moles is moles, and temperature in Kelvin, then the unit on R is going to be 0.0821. That is what R equals. If you resolve this equation, it would be PV over NT equals R, and that would be, my units on R would be atmospheres, liters over moles, and Kelvin. Right? Sometimes you can get a situation where the person wants to use millimeters of mercury instead, mmHg. Well, in this case, 760 mmHgs, or commonly known as a torricelli, equals 1 atmosphere. So mathematically, 0.0821 times 760 is 62.4. So if you want to use R equaling 62.4, then you have to have it units be millimeters of Hg, and liters, and moles, and Kelvin. So this is, I would say, a generation ago everyone used 62.4, but today with atmospheres being more and more prevalent, this is a real common constant for R. And I've already highlighted some of the units that are required for this equation: liters, moles, and Kelvin. Of course, in the combined gas law, we really only needed to have, I don't know, absolute units. As long as we're consistent, it didn't matter. In the ideal gas law here, PVNRT, it is extremely important that you have the right units, and because you have this constant R with the universal gas constant, that's calibrated for a specific type of unit. Okay, so we could simply say, example, let's try it out here. Now, one good thing about this equation is it deals with moles. So we're able to deal with moles. That's nice. Combined gas law, moles was held constant. The combined gas law also did a sort of a before-after type situation. This is not like that. So one of the things kids have issues with when they're looking at problems is you have to be able to determine which equation you want to use, combined gas law or PVNRT. Well, PVNRT is dealing with moles, so that would easily classify that as a need. Or if you're doing a sort of before and after type situation, that would be the combined gas law. All right, so let's just say we have, I don't know, let's do this once. Let's go with 1 mole of nitrogen gas. Okay, I want to know two things. I want to know what's the volume of this. Okay, and I want to know what is the let's see what's the mass of this thing. So two things I'm going to solve here. Now, again, the volume of 1 mole of a gas is varying on a lot of different things. Okay, there's temperature, there's pressure. Okay, so we're going to say at STP. That's another way of saying a certain type of conditions. Temperature is going to be 0 degrees Celsius. So in gases, STP is 0, which is not always 0. In gases, it's 273. And at pressure is 1 atm. Okay, so let's solve for the volume. I have PV equals nRT. I'm solving for V. So divide out that P, and V equals nRT over P, and it's going to be 1 mole times 0.0821. Of course, I use this because I'm using atmospheres, times 273 divided by 1 atmosphere. Okay. And when you multiply this all out, the equals, which is the volume, 1 times 0.0821 times 273 divided by 1 is going to be 22.4 liters. Okay. Now, this is a reason why I picked this problem, is because it's pretty standard that at STP, 1 mole of any gas equals 22.4 liters. Keep that in mind. Okay, 1 mole of any gas, STP, 22.4 liters. That's a pretty common relationship or ratio. Now, mass-wise, if I want to find the mass out, okay, let's do this. All right, 1 mole, and I want to get rid of moles and go to grams. 1 mole of N2 is equal to, and this is N2 is equal to 28 grams. I got that by adding up the molar mass. This is the molar mass here. It's 14 is off the periodic table, times 2 equals 28 grams per mole. That's another relationship. And so the answer is simply 28 grams will be the mass of nitrogen gas. All right, gave one example of PVnrt here. Hopefully that helps you out. Thank you.